Welcome to Factoring Club. Here we go. These are again the steps to factoring. The first step is to look for a GCF. That is always and will always be the first step to factoring. And so we'll always look for the GCF first. Step 2 is to make sure that you check to see if there are only two terms. And if there are, then are those two terms the difference of two squares? That's what you ask yourself. So when you've already pulled out a GCF first, the next step is you're going to check to see if there are two terms, and if so, you're going to see if those two terms are the difference, meaning subtraction, of two perfect squares. If they're not two terms, if there's three terms instead, then you go on to step 3. And if there are the three terms, then you try to unfoil the trinomial. What I do is I guess and check until I get there. So I just create the two parentheses and keep plugging numbers in that make sense until it foils exactly to the trinomial that I had. Now, there are some systems that some of you have, and if so, and you need consultation on that, let me know. But if you don't have a good system, then I just do guess and check by putting the two trinomials together, or sorry, the two binomials together, and foiling until I get the right one. So we're going to go through several examples here. In each one, we're going to go through each of the steps of factoring. So here we go. Factor completely. Number 1. So step 1. Check for a GCF. I'm pretty solid with my 3's, and I know that 3 goes both into 48 and into 27. And when I pull it out of 48, 16n squared minus 9. Okay, so check. I've looked for my GCF. Next step is to check to see if there are only two terms. There are. So that's what I'm looking at now. Are those two terms the difference of two squares? Let's see. 16n squared is a perfect square. 9 is a perfect square. And they're subtracting, so yes, this is the difference of two squares. So in that situation, when it's the difference of two squares, I put the square root of the first term first in each parentheses, and the square root of 16n squared is 4n. And I put the square root of the second term second in each parentheses, 3 and 3, and I make one of them plus and one of them minus. This is the factored form of this first binomial. Okay, second example. Well, I'm going to go ahead and erase my steps here, or my check marks. Back onto the second example. So for each of these, try to pause the video and see if you can follow the steps yourself, and then press play to see if you get the same answer that I get. That'll be very helpful for you so that you can test yourself out here. So hit pause now and turn it back on when you think you have an answer, and we can go through the steps together. So check for a GCF. Nothing really goes into 9 and 16 other than 1, and so I'm not going to work on that. Is it two terms? It is. Are they the difference of two squares? Let's see, subtraction, perfect square, yup. So this is the difference of two squares. Square root of 9a squared is 3a, so I'll put that here and here. Square root of 16 is 4, put that here and here. 1 plus, 1 minus. I've gone through the steps again, and I'm done factoring this one. All right, step 3, or question 3. Again, hit pause and then play it when you're ready to see how I do it. First step, to look for a greatest common factor. Let's see, I know 4 goes into both of these. I'm looking for variables too. It looks like only 4 goes into both of them, which leaves me with 9x squared minus 25y squared. Second step, is this the difference of two perfect squares? 9x squared is a perfect square. 25y squared is a perfect square. It's subtraction in between. Yes, indeed, I have the difference of two squares. So 3x and 3x, 5y and 5y, one's plus, one's minus. I have factored. Hurrah! All right, step 4. Hit pause again and then try it when you're ready. Greatest common factor, always the first step. Go through first 2. It looks like 2 goes in evenly into both of them. So I've got 16v squared minus u squared. There's only two terms, so I'm going to go to step 2 and check to see if they're the difference of two squares. 16v squared is a perfect square, as is u squared. So I've got 4v and 4v, a u and a u, one's plus, one's minus. We're just factoring very well here. I'm in Mr. Mitha's room right now, and the phone keeps ringing. It's kind of annoying, but you can deal with that. All right, number 5. What's the first step of factoring? Greatest common factor. What goes into all three terms? 1. So I'm not going to worry about the greatest common factor. The next step is to check to see if it's the difference of two squares. It can't be the difference of two squares because there are three terms. Look back up here. If there are only two terms, there are three terms. So I'm going to completely skip step 2 now, and I'm going to move on to step 3, where I work on unfoiling the trinomial. Okay? And so that is where I'm just going to set up two parentheses, and I'm going to try to make sure that I know I'm able to FOIL fast enough, and I hope you guys can get there as well, that when you FOIL quickly, you can tell what's going on and you don't have to have a specific system. So I know that when I multiply the first term in each parentheses, I have to get this r squared. So the only way I can make that happen is if they're both r's. The next step is I have to make sure that when I multiply the last times the last, I get negative 10. And so there's many different combinations to multiply to get negative 10. I can put minus 1 and plus 10. That would multiply to be a negative 10. So I know I get r squared first. I know I get negative 10 last. But when I do the outer, I multiply and I get 10r. When I do the inner, I multiply and get minus 1r. That equals 9r, not 3r like I wanted. So this was not the version I was looking for. So I don't want a 1 and a 10 there. I want something else. And we could play with it all day. But I'm pretty good at starting to get there, and I think you guys will as well, where I'm like, all right, a 5 and a 2 would work out well to make me a 3 if that 5 were positive and the 3 were negative. Let's verify real quick. Again, r squared. Look at the mistake I made. 3 wouldn't work very well at all. 2. Okay. R squared, negative 10. When I do the outer, I get plus 5r. When I do the inner, I get minus 2r, and I know those combine to be 3r. R squared plus 3r minus 10. This is what I was looking for. So make sure you don't circle the check step, circle the factored form. So I have factored this trinomial. All right, next one. Go ahead and pause the video and press play when you're ready to watch me try it. Okay, first step, greatest common factor. I don't see anything that goes into all three of those terms other than 1. Next step is to check to see if it's the difference of two squares, but there's three terms, can't be that. So I'm moving on to unfoiling. Again, the same thing, this has to be an n, this has to be an n. Now I can try many different numbers that I can multiply to be negative 48. What are some two numbers that you can multiply to be negative 48? Let's see, let's go with plus 8 and minus 6. So we multiply there, we get n squared. Here we get minus 6n plus 8n minus 48, and those combine to be plus 2n, which is exactly what I was looking for, and so we got it. So make sure we don't circle the check step, we circle the factored form. Alright, moving on. I am doing this quick, but you guys can hit pause as many times as you need to so you can make sure you're comfortable at what we're doing. Alright, number 7. Greatest common factor appears to me to be 2r, which means I'm going to pull out, and I've got 3r minus 10. So I pulled out the greatest common factor. I now have two terms left. So I need to check to see if it's the difference of two squares. Pretty quickly we can see it's not. 3r is not a perfect square, neither is 10. And so we're done. I'm not going to go to step 3 because there's not three terms here. Inside the parentheses there's only the two terms, so I cannot factor this further. All done. Number 8. Again, hit pause, try it on your own, and then come back when you're ready to see what I do. Look at the greatest common factor of these two terms. It is v. And so I pull out a v, I'm left with 3v minus 7. And I can tell again that this is not the difference of two squares, and there's not three terms. Sorry, there's not three terms, so I can't do anything else. That's fully factored now. Okay, last few here. This is when it gets a little bit more challenging, when I'm noticing that there's a number that's not just 1 in front of my x squared. But first of all, look for the greatest common factor, 299. No greatest common factor. Next step, it's not the difference of two squares because there's three terms. So go to step 3 and I'm going to unfoil. The only way to make 2x squared is if this is a 2x and this is an x. Now I got to, and really there's only one way to make 9 as well. So I'll go ahead and put plus 9 plus 1. So let's see if that works. So FOIL this. I've got 2x squared plus 2x plus 9x and then plus 9. Clearly this isn't what we were looking for because this adds up to be 11x. So we're going to have to try something else. Now I realize what I said a second ago was false. There's more than one way to make a 9. Not just 9 and 1. I could try 3 and 3. So let's see, 2x squared and 9 at the very end, and I get a plus 6x there, plus 3x when I multiply the inner terms, and that adds up to be positive 9x, which is pretty close, but I wanted a negative 9x. So what do you think I could do to make it be a negative 9x instead? If you said make both 3's negative, you are correct. So a negative 3 and a negative 3. Now when I multiply the negative 3 times 2, I get negative 6x. And the inner terms, I get negative 3x. The last term is still negative 3 times negative 3, so a positive 9. So I'm good there. But these negative 6x and the negative 3x adds up to negative 9x. And this is what I was looking for. So it's just, again, that guess and check process. Keep foiling until you get the one you're looking for. All right, number 10. Looks like the greatest common factor is at least 2, maybe more. They're all even numbers, so I'm going to pull out a 2. That leaves me with 5x squared minus 39x minus 54. This is going to be a fun one. Let's see. It's not 2 terms, so I'm going to skip right over step 2, and I'm going to go straight to make sure that trying to unfoil. So I'm going to put a 5x and an x because that's the only way to make 5x squared. Now, there's lots of ways to make negative 54. The one I think of the first is 9 and 6. So I'll try 9 here, and I'm going to try a negative 6 there because I want a negative 54. So let's FOIL this. I know I'm getting the 5x squared. I know I'm getting the negative 54. I'm going to ignore the 2 for now because it's just sitting out there. My biggest concern is what happens when I multiply the outer and the inner. When I multiply the outer, I get negative 30x. The inner, I get plus 9x, but those combine to be a negative 21x. And that's not what I was looking for. Oops. That's not what I was looking for at all. And so we're going to try something else. What if we switch their places? Let's go with a 9 here. Ooh, I changed my colors. I don't want to do that. I kind of stay the same color here. Let's go with a 9 here and a negative 6 there. So now when I multiply the outer, I get plus 45x, and I get minus 6x. Those add up to be 39x, but I wanted a negative 39x. If that ever happens and you end up with the exact opposite of what you wanted, just switch the signs. We're going to go ahead and make it a positive 6 and a negative 9. That gives us the negative 45x when we multiply the outer terms, and a positive 6x when we multiply the inner terms, and so we're left with what we're looking for, the negative 39x here. So the fully factored form is right here in front of us, and we're done with number 10. 2 more. Let's see if we can get this done. School's almost out, and I'm in Mr. Mitha's room, which is the CP room, so people are coming soon. I got to be careful here. All right, let's see. Step 1, GCF. It looks like all these guys have a p in front of them. 4p squared plus 23p minus 6. Again, pause the video here. Try to do this on your own. Okay. All right, so I'm going to skip over step 2 because it's definitely not the difference of 2 squares. Let's try, I'm going to actually go 4p and 1p here. I've got like a little bit of a premonition because I realize if I do a plus 6 here, when I multiply these together, I'm going to get a positive 24. That means this would be a negative 1, and that would multiply to be negative 1p, and I'd add those, and I think I get the 23 I'm looking for. Let's check. So it would be 4p squared plus, 24p minus 1p minus 6 when I FOIL all this out. The 24 minus the 1 is 23p, just like we were looking for. So that's the one that's the step we were looking for. So we are going to go ahead and box